Sometimes we're not interested in the individual orbital and spin angular momenta by themselves, but in the total angular momentum. We call that J. So J is the total of the orbital angular momentum and spin angular momentum. And here I have it totaled up for many different electrons in an atom. So this is an atom with Z electrons. So I have Z different terms with the orbital angular momentum and Z different terms with the spin angular momentum. Here's an illustration that shows how the total angular momentum will point in one direction and the effective magnetic dipole from that total angular momentum points in roughly the opposite direction. We should be a little careful with this, however, because we've seen that for orbital angular momentum, we only get half as much magnetic dipole moment per unit angular momentum as we do for spin angular momentum. What that does is that'll make these two vectors not point in exactly opposite directions. If the total angular momentum comes more from spin, we'll get one effect. If the total angular momentum comes more from orbital angular momentum, we'd get a different effect. So it is possible for this mu effective to point in a noticeably different direction from the total angular momentum. However, there is something rather nice that happens in most atoms. In most atoms, many of these different angular momentum vectors will cancel out, and only the angular momentum from the orbit of the outermost electrons and the spins of the outermost electrons matters. All the interior ones tend to add up to 0, and so we can look at the terms only from a few electrons with the highest energies to figure out the total angular momentum of the atom and the total magnetic dipole moment of the atom.